there is a history of oil and gas projects not achieving the outcomes promised at the final investment decision. Although research has demonstrated the effectiveness of using front-end loading and decision analysis to improve outcomes from projects, they are not always fully applied. The premise for this research is that there may be an over-reliance on expert judgment for decision-making, leading to suboptimal outcomes. This research is looking to verify how decisions are being made, how front-end loading and decision analysis are being used, and why. The results will be used to develop ways to influence decision makers so that front-end loading and decision analysis are applied more effectively in future, and hence the promised outcomes are more likely to be achieved. Most oil and gas companies use a decision-gated framework which typically has 5 phases. Each phase is separated by a decision gate. There are 2 key questions at each decision gate. Firstly, are you ready to proceed to the next phase, i.e., has all the necessary work been done to enable a quality decision to be made? Secondly, do you want to proceed, i.e., is there value in proceeding, taking account of costs, benefits, uncertainties and risks? Front-end loading is about significantly investing effort in the phases that lead up to the final investment decision. For an oil and gas development, this means that sufficient work is done to confirm that the selected development concept will be suitable for the full range of potential subsurface outcomes. It means that well design does not commence until there is sufficient subsurface definition to finalise well targets, and facilities design does not commence until there is an appropriate level of definition of volumes, throughputs and fluid properties. However, if front-end loading is not carried out sufficiently, there are 2 main drivers of lost value: selecting and executing the wrong project, even if it is executed well, and changes required due to an incomplete level of definition, meaning that rework is required. This leads to longer schedules, higher costs, and what has most impact on the bottom line is the reduction in production attained. In 1954, Paul Meehl reviewed the results of 20 studies that analysed whether predictions by trained professional clinical psychologists were more accurate than mechanical means of prediction. The results showed that, even when using a small amount of information and a simple rule, the results are better for statistical prediction. Since then, over 200 studies have been carried out on a wide range of subjects, including longevity of cancer patients, football game results, and future wine prices. About 60% have shown significantly better accuracy for algorithms. The other comparisons score a draw. No exception has been convincingly documented. This has interesting implications for the front-end loading scores calculated by Independent Project Analysis, IPA. Their front-end loading score has been shown, based on many thousands of projects, to be a good indicator of the likelihood of a successful project outcome in terms of cost, time and production attainment. It is much more than a simple model and has demonstrated statistical validity. Despite this, a large number of projects are allowed to proceed to the next phase without completing front-end loading work. Why this happens is one of the key questions being addressed by this research. Part of the answer may be in the way that we think and the way that our brains are wired. Daniel Kahneman coined the phrase thinking fast and slow. System 1, thinking fast, uses the subconscious mind. It is intuitive and automatic and low on computational power. As an example, if I'm asked what 2 times 2 is, I instantly say 4. I don't need to think about it. System 2 has great computational power and accuracy, but is slow and interferes with other thoughts and actions. For example, if I'm asked what 23 times 49 is, well, I definitely need to stop and think about that. Both systems are useful. However, humans are cognitive misers, and we tend to default to System 1. Our brains are hardwired to be effective and protect us. There are 2 paths that go from the sensory thalamus to the amygdala. One is direct route. This is quick but has minimal process. It tells us in this instance, that there's a snake in our path and so we jump back. It protects us. There is a second link that goes from the thalamus to the amygdala via the cortex, which is responsible for information thinking and processing. This is slower but more accurate. This then tells us that it is not a snake but a rope. However, that initial response could have saved our life, so it's very good to have both pathways. Neuroscience also tells us that we may not always be right. Ulrich Nieser carried out a study on the Space Shuttle Challenger disaster. 106 students wrote down their memories of what happened, where they were, how they felt about the event, and details of the event. They did this both one day immediately after and 2.5 years later. 25% of them were strikingly different. 50% had lesser errors, less than 10% had all details correct. And prior to being handed their original scripts back, most students presumed their memory was correct. We are also fooled by this feeling of knowing. This feeling of knowing can be spontaneously activated by direct stimulation of an area of the brain or by electrical manipulation, but it cannot be triggered by conscious thought. A lot of work was done on heuristics and biases by Daniel Kahneman and Amos Tversky. Heuristics are shortcut ways of making decisions, where you substitute a simple question for a difficult one. Biases are the unwanted result of these. An example of using a heuristic is in choosing US presidential candidates. It's difficult to judge how good somebody will be as a president, and so a heuristic commonly used is that tall, strong, good-looking men are people that you can have confidence in, and so would be a good president. This might have worked okay for John F. Kennedy, but maybe not for Ronald Reagan. Overconfidence is a common bias. An example of overconfidence is that 82% of people say they're in the top 30% of safe drivers. To help overcome these biases, we need to take a structured approach. This is where decision analysis comes in. The diagram is by Ron Howard, one of the founders of decision analysis. For a quality decision, you need all 6 aspects. There must be clarity on the frame. What is the correct background, setting and context for the decision? Then there needs to be clarity on all 3 legs of the stool. What you want, i.e. what is valuable to you, and how would you trade off between conflicting values? What you know, and in particular clarity on what you don't know, and what you can do. Are the creative doable alternatives? If there are no alternatives, then there is no decision to be made. These are all held together by logical reasoning to determine which alternative will create the most value. Then commitment is required to move decisions to actions. The best decision is useless if an organisation will not implement it. The decision quality wheel maps one-to-one with the 6 aspects of decision analysis. You use the decision quality wheel to determine whether each of the 6 aspects of decision analysis has been addressed sufficiently to enable a quality decision to be made. The previous few slides have shown some general reasons why front-end loading and decision analysis may not be used more effectively. I want to find out specifically how decisions for oil and gas projects are being made, and what use is being made of front-end loading and decision analysis, and why. This will initially be done through some qualitative interviews using open questions. The findings from this will be used to develop a quantitative survey which can be completed online. The results of the survey will then be used to design incentives and nudges to influence decision makers to make better use of front-end loading and decision analysis. Experiments will be set up to determine the likely effectiveness of these. This research is being carried out by David Newman as part of a PhD programme in the Australian School of Petroleum at the University of Adelaide under the supervision of Professor Steve Begg and Dr. Matthew Lewis. If you are involved with oil and gas projects and are interested in taking part in the interviews or surveys, then please contact me on the email address shown, dnewman@adelaide.edu.au. Thank you.